In this video, we will talk about representation of a sparse matrix, and also we will see how to display a sparse matrix from that representation. This topic we have already studied in arrays. Now again we are learning it in linked list. I have an example of a sparse matrix of size 5 cross 6, that is 5 rows and 6 columns. A lot of elements are zeros, only few elements are non-zeros. 8, 7, 5, 9, 3 and 6 and 4. Just 7 elements are non-zero. Now how to represent this? So for representing a sparse matrix, we want to avoid storing zeros. We want to store only non-zero elements. For example, if I take this element, this is non-zero. So for representing it, we should know what is that element, and also we should know where it is in the matrix. So for that, I should know the row number and column number. So 0, 4 is 8, and this 7 is 1, 3. First row, third column, value is 7. So for every non-zero term, we should know row number and column number, and then the non-zero term. So we have to represent this one such that we should be able to regenerate the same sparse matrix. So let us see how we can represent this one by just taking non-zero elements. So I will draw the structure and show you. For representation, I have taken an array of size 5. This array is representing rows. There are 5 rows. So the indices in an array represents row number. Now for representing non-zero element, like example 8, I need to know column number and the element itself. So column number is 4 and the element is 8. So that I will represent it as a node. Fourth column, element is 8 and this is null. So this is a node containing column number and the non-zero element. Then next row, row 1, there is one non-zero element at column 3. So here we have a non-zero element at column 3. So column 3 element is 7 and this is null. Then in row 2, we have two non-zero elements at index 0 and 4. 0, the value is 5, and next at column 4, value is 9. The next row, we have an element at column 5. Then in this row, we have two non-zero elements at column 0 and column 3. So this is the structure. So this is a linked list. This is another linked list. This is another linked list. So all these are linked lists. So it's an array of linked lists, and the name of this array, if suppose it is A, then this is also A. We can call it as A is an array of linked list. Now how we can form this structure? This structure is having collection of linked lists. So linked list is a collection of node. So the node structure, this contains what? Each node contains column number and non-zero element. So if I define a node structure contains three things: column number and the value and next pointer. So using C language, if I define a structure, this is structure node will contain three elements. One is column number and value and a next pointer. This is a node, this is a structure. Now how to create this structure? For creating this structure, I need an array of number of rows size. If this is m cross n, then I should have an array of size m. So let me create this array of size m. So array is of type node pointers A of size m. So this is an array of pointers of size m, whatever the size is. So this will be an array. Then at each location, let us say A of 0, assign this new node. So I am just assigning just one node. Like this, I have to create all these linked lists. So you can write a program, you can write a procedure for creating this type of structure. I have just given the idea here how we have to create this one. Create an array of pointers, then at each location create a linked list of non-zero elements. So you can write a program that is taking input from the keyboard and asking what are the non-zero elements. From keyboard, you can take row number, column number and the non-zero element. So for a given row number in that particular row, that is in that particular index, you can create a node having column number and the non-zero element, and you can form a linked list. So this is a student exercise for creating a sparse matrix, adding two sparse matrices or displaying sparse matrix. These are the things that you have to do. So I'll just list out. So these are the three things you have to do: create sparse matrices, so then you should be able to create more than one, then display, how to display the sparse matrix, and how to add two sparse matrices. Out of this, I will just share the idea how to display this one. So I will write on the piece of code for displaying this sparse matrix. Let us see how to display. So for displaying, I should display all these rows. So for all these rows, for I assign 0, I is less than m rows are there, I plus plus. This loop will cover all the rows. Now in each row, what I should do, I have to scan through a linked list. Let us take this example, it is having more than one node. So scan through this one. So take a pointer at the beginning. So I need a pointer. So let us take a pointer P. Let us take a pointer P. For example, I am showing it here for this linked list, right? Pointing here so that I can get it from A of I. So at A of I. So P is pointing here. Okay, let me show it here. This is outside. So we have to do it for all. But here you can see it. So I am showing it here. So for displaying all the elements in a column, I should repeat it for n times. So I want to display zeros also. So for that, take one more for loop for j assign 0, j is less than n and j plus plus. So this will repeat for total n times, that is equal to number of columns. Then at each column, I should see that if that is non-zero or zero element. So if it is non-zero, I should print the element. If it is not, I should print 0. So how you can know is it non-zero or not? So this P is pointing upon some node that will show me. So the column number. So here what I should do is, if J is matching with the column number, so that is P is a column, P is a column, this is column. If it is matching with P's column, then print the data here, non-zero element. So print the value, non-zero value, and also move P to next node. So printing the value and moving P to next node. This I have to do if this is true, if the column number is matching. If it is not matching, else I should print 0. Else print 0. That's all. This is simple. So I will trace this one little bit. Just watch it. I is starting from 0. So I is here. Then P assign A of I. So P will be pointing here. First one. Then for j assign 0 to n. 0 to n means 0 to 5 it will go. J will repeat from 0 to less than n. So 0 to less than 6, that is 5. So it will go up to 5. Then what it is doing? First time j is 0. Yes, j is 0. So is it matching with P's column? Is it matching with P's column? No, it is 4. So print 0. 0 is printed. Then next j plus plus, j becomes 1. Then check if j is equals to P's column. J is 1. Is it equal to P's column? No. Print 0. Then j becomes 2. J plus plus. Then j is equal to P's column. P's column is 4. So up to 4 it will not be matching. So it's not matching. Then print 0. Then j becomes 3. Print 0. J becomes 4. It's matching now. So print 8. And move to next node. So P will move to next node and P became null. P became null. Then next, this becomes 5. Is it matching? No. Print 0. So that's how it will print all these things. That's how it can be displayed. So I have just given the idea how to display this sparse matrix. Complete matrix 0, 0, 0, 8, 0. All the values are printed. Zeros as well as non-zeros. So rest of the thing is an exercise for you. Write a complete program and also write a program for adding two sparse matrices. In this video, we'll learn about polynomial representation using linked list. This topic we have already covered in arrays. If you have not seen that video, you can watch it, polynomial representation using arrays. So now let us represent it using linked list. Here is an example polynomial. This is a univariate polynomial. It is defined in terms of just a single variable x. So it is summation of terms. There are more than one terms being added together. If we know the value of x, we can evaluate and get the result of that polynomial. We want to represent this in our applications. So for representation, we have to store the data about that polynomial. That data can be stored either in an array or linked list. So array we have already seen. Now how to represent the data related to polynomial in a linked list. So if we observe a polynomial, each term is having its coefficient and exponent. Then if we know the value of x, then we can raise the value of x to the power, that is exponent, and then multiply with coefficient. So we can get the answer for just one term. Like that we can evaluate all the terms and get the result. So it is sufficient to store coefficient and exponent of each term. So these terms we can represent them in the form of a linked list. So for that, we can define each term as a node, and these are set of nodes. So let us define a node for one single term. Here is a node having coefficient, exponent, and a pointer to a next node. Let us define a structure for this one. This is a node having integer coefficient, integer exponent, and a pointer to a next node. See, I have taken integers. If you feel that coefficient is a float, you can take float also. Now one more thing you can observe, this is a node of a linked list and is having three members now, coefficient, exponent, and a pointer. So far, whatever the linked list we have studied, that time we were taking only one value. But now we are using a linked list. So based on the requirement, a node can have any number of data members. So now let me represent this polynomial as a linked list. Here I have a linked list of these type of nodes where each node is having three sections. This is for coefficient, exponent, and a pointer to a next node. So there are four terms in a polynomial. I have taken four nodes. Let us fill up the values from that polynomial. First coefficient is 4 and the exponent is 3. So this is 4 comma 3, and this is 9 2, and this is 6 and power is 1. So 6 and power is 1, exponent is 1. That is 7 and exponent is 0. That is 7 and exponent is 0. This is how it can be represented. If you remember, in arrays, we were also storing how many terms are there. Here we don't need to store. If you want, you can store it somewhere else. Otherwise, the number of nodes are equal to number of terms. We will not have any extra nodes here. So that's all. This is the representation. Now we will learn how to evaluate a polynomial. Already we have a polynomial and this is represented using a linked list using this node structure. Now if we know the value of x, then how we can get the result of this polynomial? If suppose x is 1, then this will be 4 plus 9 plus 6 plus 7. If x is 2, then it will be 4 into 2 cube plus 9 into 2 square plus 6 into 2 plus 7. That's how I have to evaluate this one. I will show you the procedure and also write a function how to evaluate this one. Let us look at a procedure. Suppose I know the value of x. X is something, let us say 2, 3, whatever it is. So for getting the result of this polynomial, I should raise this 2 to the power of 3. I should take 2 power 3 and then multiply the result with 4. Then go to next node. Then 2 power 2, multiply the result with 9. Go to next node. 2 power 1, then multiply the result with 6. And then they go to next node. 2 power 0, multiply the result with 7. So I have to scan through the linked list. At each node, I should raise the value of x to this exponent and the result should be multiplied with this coefficient. And add all the values, I get the result. So the procedure is very simple. So I will write a function here for evaluation. Here is the function. Function name is evaluation, that is eval I have taken, which is taking a parameter x, the value of x. Then I have some temporary variables, that is sum, for finding the sum of all the terms. And I have taken a pointer q, that is pointing on p. I have taken the name of the first pointer as p because it's representing a polynomial. So Q, I am taking it as a temporary pointer for scanning through this list. So Q will be pointing here. So Q will be accessing a term and moving to the next term. In this way, it will scan the whole linked list. So let us do this process. So we know well that whatever the value of x, that should be raised to the power of this one. So find out power of x comma q's exponent, that is q's exponent, q caps exponent. This will find out the power. Then this should be multiplied with q's coefficient, this coefficient, that is coefficient. So q's coefficient. Then this result, whatever we get just one term, and this should be added in sum. So sum plus. That's all. This is the expression. It will evaluate one term. Then I should move q to next term and do the same thing. Q assign q's next. So q will move to next node and again repeat the same thing. So I have to repeat the same thing, means it should be in a loop. So I will write a loop. How long this loop should work? Until q becomes null. So while q is not null, while q is not null, while q not equal to null. Continue these two steps. That's all. This will evaluate a term, move to next term, then evaluate a term and move to next term, then finally return the result sum. So that's all. In this video we have learned how to represent a polynomial and how to evaluate a polynomial. Now adding two polynomials, that is a student exercise. We have already seen that in an array. So here upon a linked list, it will be similar only with some minor changes because this is a linked list. So you work out on it and write down the program for adding two polynomials, evaluation of polynomial. In this video, we will develop a C language program for implementation of polynomial evaluation using linked list. So already we have done this using array. Now I will show you how we can represent a polynomial and also how to evaluate this one. And one more thing, addition of two polynomials will be a student exercise. You have to do it. So let us start a new project and call it as polynomial linked list. So poly LL I have given and the language is C language. Create a project. This is the main function. I'll clear off these comments. Now for representation of polynomial, we have already seen the node structure. So I will define a node structure for a polynomial. It needs a coefficient, so I can take a coefficient as integer or float, whatever it is. So I have taken integer here and an exponent. Then next is a pointer to next node. Then for representing a polynomial, I should have a pointer of type polynomial. So I will call this as poly. Instead of first, I am taking a pointer as poly and let it be initially null. Then how to create this one? I should be able to create it. So here let us write one function for creating a polynomial by taking input from the keyboard. So I will call the function name as create. This function will access a polynomial, this pointer globally. So here we will take the terms. Each term will take a coefficient and exponent and create a term. And each time we will be adding a new term at the end of a linked list. So for that I need some temporary variable, that is pointers. So I will take pointers struct node, a pointer for creating a new node and a pointer to point on last node. And also I have to take integer variables like the number of terms. For number of terms I'll declare the variable. Anyway, when we use these variables, you can understand why I have declared these variables. Now first of all, we should know how many terms are there. Printf enter number of terms. So I'll give a message and ask how many terms are there. Then whatever the number of terms are there, we will take it in a variable num. That is, num will have the number of terms. So as the number of terms are given here, I should create those many terms and prepare a polynomial. Now I have to do this in a loop, so I can use a for loop. So for that I have declared a variable I. Then next I'll give a message printf enter each term with coefficient and exponent. So we'll be taking all the terms by taking their coefficients and exponent. And using for loop, I'll do that for I assign 0 and I is less than number of terms and I plus plus. For each term, I should create a node and store the coefficient and exponent in that node. So for that, I will first create a new node. Now node is created, then I should read the data, that is coefficient and exponent. So using scanf, I will read two values, that is coefficient and exponent. So inside t's coefficient and t's exponent. Then now I have to link this node in a linked list. So first of all, I will make t's next as null because it's going to be a last node. Then I have to link it. So either it may be a first node or I have to insert it after last. So first of all, I will check that if poly is equals to null means it's a first node. If it's the first node, then poly should point on, that is the first pointer should point on t, as well as last pointer should also point on t. So I'll make both of them point on that first node. Otherwise, it has to be inserted as a last node. So for last node, I should say last next assign t and last should point on t. That's enough. So this will create a polynomial. So this will create a new node and insert it at a last node. Then I should have a function for displaying a polynomial. So I will write function here for displaying polynomial, void display struct node pointer p. It will take a pointer, then it will print all of the terms in a polynomial. So while p, print all of them. So printf percentile d, then x, then in percentile d, then plus for showing the next term. I'll remove spaces in between them. Then here I should display p's coefficient as well as p's exponent. That's all. Then after this, p should move on to next node. That's all. At the end, I should give a line gap, so for proper formatted display. So that's it. I have a function for creating a polynomial by adding term by term and then displaying all the terms. So just inside the main function, I should call a function create, which doesn't take any arguments, and I should write a function display, which should take a polynomial as a parameter. Let us run this program. Here it is asking for terms, so I will say 4 terms. Now I should enter coefficient and exponent. So coefficient is 2 and exponent is 3. Then coefficient is 2, exponent is 2, coefficient is 2 and exponent is 1, coefficient 2 and exponent is 0. So these are the 4 terms. So I got 2x to the power of 3 plus 2x to the power of 2 plus 2x to the power of 1 and 2x to the power of 0. Yes, it's perfect. Here I got 2 warnings because of malloc function and the last which may be not initialized. So I should declare it as assign with null. I am initializing it. Then also I should include header file, that is stdlib.h. Now let us write a function for evaluation of polynomial. So I will write a function called eval. So return type is integer, or I can make it as long because the value may be little bigger. Struct node pointer to a polynomial. This will take a parameter. And also I should pass a value for which I want to evaluate, that is the value of x. Now for evaluation, I may be getting a longer value, that is larger value. So I will declare a variable val as long, where I will get the result of a polynomial in this variable. Now for scanning through a polynomial linked list, I should have a while loop. Then while I should evaluate the terms and I should store them or add them to this val variable. So for terms, p's coefficient is multiplied with x to the power of exponent. So I should call the function par with x comma p's exponent, and p should move to next node. That's it. So instead of displaying, I'm evaluating them and storing the result in val. Then finally it should return the result, that is val. Now inside main function, I will call this val function. Then here I will call eval function and directly I will print its result. So printf percentile ld, because it's going to return a long value, and also I'll give a new line. Then next I should call eval function. For that I will send a pointer to a polynomial, that is to a first node, and the value of x I will pass it as 1. So whatever the coefficients I am giving, I should get the sum of the coefficient if the value of x is 1. Let us run. Now I will enter the number of terms, that is 4 terms. Now coefficient is 3 and the power is 5, coefficient is 2, power is 4, coefficient is 2, power is 3, coefficient is 2 and the power is 0. Now if you see, we are evaluating it based on the value of x as 1. Yes, value of x is 1. when x is 1, then I should get the result, that is sum of the coefficient, that is 3 plus 2 plus 2 plus 2. So that is 9. I should get the result as 9. So let us check. Yes, I got the result as 9. It's perfect. Then we can try with different values and check it. So that's all with this evaluation of polynomial. So we have seen various functions here, that is representation of polynomial we have seen, then creation of a polynomial by taking the inputs, and display function and evaluation function, and this value should be initialized to 0. That's all. So practice this program.